And reality. New stories, new ideas. Little Beth Entertainment.
Welcome to the first episode of Season 10 of The Rocketry Show at TheRocketryShow.com. Boy, do we have a treat for you. On this episode, we're joined by Vance Martin, who's an amateur radio operator, and he's got an interesting project going on that's near to my heart. He's got a radio telemetry project of his own. It's quite advanced and further along than mine, and it's a great listen. Stick around. The Rocketry Show, Episode 1 of Season 10, will start right after this.
The Rocketry Show thanks rocketryforum.com for their support. This is Jim, and I've been a member for 9 years. The Rocketry Forum is a global community of rocketeers who openly discuss all aspects of hobby rocketry. If you have a question, hop on and ask. There are hundreds of experts who can answer just about any rocketry question you have. Check them out today at rocketryforum.com.
Ignition sequence start. 6, 5, 4, 3, 2, 1, 0. All engine running.
Welcome to The Rocketry Show.
All right, lift off and the clock is started. Yes, sir. Reading loud and clear.
A podcast that is all about advanced and high-power rocketry. Amateur-built rockets, starting at mid-power to higher-power versions that can reach the edges of space. This program is hosted by the team who love the smell of burning ammonium perchlorate in the morning. Here are CG, Gene, and model rocket guy, Jesse Yu.
Welcome to The Rocketry Show at TheRocketryShow.com. I'm CG.
I'm Jim.
And Jesse Yu is busy with work. That's been... Well, we've all been busy with work. That's kind of why... one of the reasons why the show has been kind of so slow to come out with you, you know.
Yeah, if it wasn't for this work thing, we could do stuff we really want to do.
Yeah. So as you know, about 2 years ago, I started a new job after the old one went away during the pandemic. And in the new job, I've just been busy cranking through products for the last couple of years, and I've been slowly coming up for air from all that. So the shows are happening a little bit more frequently now. And Jesse, during that same time, well, yeah, as we got closer to now, his job has just kind of become like the grind. I mean, he loves what he does, but
Is he?
Yeah, but it's definitely consuming more and more of his time right now. So there you go. That's what we've been up to. But we have a great show on the way here, and this one's kind of right up my alley. Our guest here is someone I found while tootling around on Mastodon social, and you know, as the whole social media landscape has been shifting and everything else, you know, dramatically for various reasons, and I'll leave it at that. People have been trying out different places to go and socialize. And, you know, it's funny because I don't know if social media is ever going to go anywhere back to what it was. I think it's going to be a lot of private rooms that people are in. But anyway, in my tooling around, I ran across a ham radio operator, callsign N3V as in Victor, E as in Emerald, M as in Mike, N3VEM. And he's a born-again rocketeer, and he's been taking his ham radio experience and applying it to rocketry. So our guest is Vance Martin, and welcome to the show, Vance.
Hey, thanks for having me, guys. I'm actually pumped to be on. I, like you said, being born-again rocketeer in all sense of the words, I stumbled across your podcast a few months ago, and when you reached out to me, I was excited. Said, "Yeah, heck yeah, I'll come on and chat." Cool. So I'm thrilled to be here.
Yeah, I saw you on there, and I saw what you're up to, and I just kind of just looked through this site and just kind of follow what you're doing. It's like, okay, this person is definitely going to be a great guest to have on. So I had you on my radar there. So basically, give us an overview of what you're up to with your rocket project, and we'll take it from there.
You bet. Yeah. So, you know, like you said, I'm primarily a ham radio operator, and my, had done rocket stuff as a kid and a teenager, built a rocket for high power level 1 certification when I was like 20 and never launched it. So never got certified. It sat in the corner and my kids basically found it in storage within the last year or so and said, "What is this?" So I, had to kind of explain it to them. But having been into ham radio for the last few years, when I started building, the rockets and then the mid-power rockets with the kids, basically I was like, well, I need an excuse to stick some radio stuff in the rockets because that's kind of what really gets my goat. So that's essentially where the project started was, hey, I want to stick some radio stuff in the rockets. I'm like, well, what am I going to do with the radio? Because you can't really like talk to the rocket. So the obvious thing was, well, let's use the radio stuff to send some telemetry stuff and, maybe do a little bit of GPS stuff. There's all kinds of little ham radio GPS, communication protocols. So there's just all kinds of little electronic stuff to dabble with. So it turned out to be a pretty natural fit. And being a DIY person, I looked around and saw all the off the shelf stuff that you can buy to do telemetry and rocket tracking and things like that. But I thought, well, for me, the fun is in building it. So I'm going to build something. And if I can build something that's half as cool as some of these commercial products and learn something in the process, that'll really get my goat. So that's essentially how the project started.
Yeah, when people ask me a lot when they see me working on stuff, it's cool. And they see how much time I spend on it. And it's like, well, you can buy something like that does the same thing. And I was like, yeah, I know, but it's not that much fun. And it's expensive. So
you could also buy a rocket and shove a motor in it too. But
I was just going to say, why don't you just buy a ready-to-fly rocket then?
Yeah, exactly. Right? Yeah, great comeback.
Like that's, the fun is in the building of the thing. If I just wanted to shoot stuff in the air, like I could do that with firecrackers.
Yeah.
Yeah, but you wouldn't be following the NARC code with that.
Well, no. Yeah, there's way more fun stuff to do than that for sure.
Yeah, where's the challenge there? So, what was your first project? Your first step into that? When was that, and what was it?
So it was, it was about a year ago, I guess, at this point. And the first step was, when I started building some of these rockets with the kids, I said, well, I want to, stick, some radio stuff in a rocket, and in ham radio. APRS is a system that a lot of ham folks use for telemetry tracking. Now, they're usually using it to track their vehicles. It basically gives, GPS position reports, and it can send whatever type of data you want. So my initial thought was, hey, I'm going to stick one of these ham radio APRS trackers in the rocket and maybe tweak the code because a rocket goes up and they're designed for cars to go, down the road. So that's where it started. And initially, I had, from when I got into mid-power rocketry, I had an Aerotech initiator, one of their kind of flight sets
Classic.
that they have. So that's how I got into it. So I still had that initiator rocket. So literally all I did was buy an extra length of body tube so that I could add a payload bay onto that initiator rocket. And that was what I called Radio Rocket version 1. And it was very rudimentary as far as the electronics in it. There was a small microcontroller, off the shelf, the Feather series microcontrollers from Adafruit for anybody who's into that kind of stuff. And then some of their little breakout modules, and a device called a light APRS, which is like a little single board APRS tracker. So I basically stuck them to a board, kind of standard, eBay sled style construction. And that was the first version of the radio rocket. But unfortunately, I made what are probably some rocketry noob mistakes when I was building that. And the electronics worked fine, but the recovery did not deploy. And so I got the data until I didn't.
Right.
Yeah.
So really it was a construction thing. When I designed the payload bay, I did kind of the standard, like the end caps that basically had the smaller one inset so that it would kind of sit flush on the end of the coupler. But I think what happened is when I tightened the ends on to launch it, I tightened them too far, and I think it flared the ends of the coupler.
Yeah.
And it was just too tight. And because I hadn't been in rocketry for so long, somebody else probably putting it together would have said that friction fit is too tight. That's not going to come apart. But I didn't know any better because it had been, 15 years since I launched a rocket. And so it basically didn't deploy and came down just as fast as it went up. So that was version 1 of the rocket.
Okay. Learned a few lessons there.
Yep. So then basically from there, even before I actually launched version 1, I had started building version 2 and did a little bit more digging and, again, fairly standard construction stuff as far as building an electronics sled. The biggest difference being when I started version 2, I also built then the ground station. So in the rocket itself, I had for version 2, I had upgraded to it's a company called PJRC, and they make a microcontroller called the Teensy. So I used their Teensy microcontroller because it's long and skinny. So, I'm a mid-power guy. Everything I do has to be like small because I'm trying to pack it into like 38 millimeter airframes. So all of this stuff I'm building will fit in a 38 millimeter rocket because I'm trying to keep them small.
Right.
But anyway, so I used that Teensy and then the Adafruit breakout boards, and I basically just had them on a long piece of wood that became the sled, kind of like essentially glued on, just, going down the piece of wood.
Sounds familiar.
It worked pretty well, straightforward. And then for the ground station, I used one of the single board computers. It wasn't a Raspberry Pi. It's one of the Raspberry Pi knockoffs because if you're into making stuff, Raspberry Pis are kind of like unobtainium right now.
Right.
Yes.
So I used one called a Libre Computer Lay Potato, which is very similar in form factor. But
great name.
So the ground station is basically a project box with one of those single board computers in it, 2 radio receivers. So I used LoRa for the telemetry, which is, a modulation technique. And then I used the APRS, which is on the ham radio 2 meter frequency band for the APRS stuff. So in that ground station, I had basically a little SDR radio dongle to receive the 2 meter APRS stuff, had the little LoRa chip connected to receive the LoRa data. And then I actually fed that all into Node-RED. So for anybody who may or may not be familiar, Node-RED is basically a low-code programming language, for lack of better term, where you can visually basically put like code blocks together. So basically in the code, there's a block that says, okay, get the serial data from the LoRa, and then, send the packet this way if it has this information, this way it has if it has this information. And you can build a visual dashboard with like little gauges for your magnetometer readings, your accelerometer. You can do the math for altitude stuff. So you can basically do it all in Node-RED there. And then it gives you like a nice real visual real-time dashboard. So with version 2 is when I kind of got into that, like having a dashboard that I could watch to see what was happening. So yeah, that was version 2, and we launched that rocket 3 times. So the first 2 launches went pretty well, and the third launch, the data went really well, but I ejected my motor instead of the parachutes on the third launch.
Yeah.
So, which was an interesting, again, another rocketry learning thing. So I built that rocket with a 38 millimeter airframe. And I figured, hey, I'm going to build this thing so that if I do level 1, I can stick a 38 millimeter H in this rocket, but I'll just use an adapter for 29 millimeters. So I was using the little AeroPack retainer things, but I was using kind of what I would call a generic spacer. So I wasn't using the AeroPack adapter. I was using basically a cardboard and wood adapter, and the back spacing ring was almost like too thick, so the retaining ring wouldn't quite thread on the whole way. So I was always like adding extra tape around the retaining ring to keep that on. And the last launch, it just didn't hold, and motor shot out the back, and that was it for version 2, which wasn't the end of the world.
Was that a motor deploy then? You didn't have any kind of ejection charges electronically controlled?
No, I had in the stuff that I've been building, I have the relays and stuff to fire charges.
Right.
But I've just been basically testing them to make sure they work. I wasn't relying on them for ejection.
One step at a time. Got it.
Yeah. So I've just been using the motor ejection until I'm confident that the little it's not relay based, it's transistor based circuits that I'm using to fire igniters. So
I got a quick question about the LoRa, because I was fascinated. I have a LoRa tracker, just an off-the-shelf one, and I'm curious, like, what its line of sight, like reception is, because I hear a lot of stuff about this, and it's like, really, that much? I mean, and why that works?
Yeah, so it's line of sight, like you said. So if you're, in trees, once it's on the ground, the range can be somewhat limited, but while the rocket's in the air, the line of sight can be, several miles. The catch being there's kind of like 2 versions of LoRa you can use.
Okay.
So there's what I would call, well, not anybody would call, there's the 900 megahertz LoRa, which you can use even without a ham license. The 900 megahertz modules anybody can use. And then there are 70 centimeter, which is like 433, 434 megahertz modules that are in the ham band. So you have to have a ham license to use those.
Okay.
And this gets into the nerdy radio stuff, but
that's why we're here.
70 centimeters, the ham frequencies, by their nature, will propagate further than the 900 megahertz frequencies.
Okay, that's what I thought.
So all things being equal, the ham radio band ones will go further, and can be several miles with just the basic chip running at a number of milliwatts. The cool thing with the ham radio piece, and one of the things that I haven't gotten into yet but is on my slate for this project, with ham radio, we're permitted to run obviously a lot more power. So in theory, I don't know how I would make it fit in a 38 millimeter airframe, but in theory, I could run 1,500 watts of power of LoRa and send signals.
Many light bulbs.
Yeah, exactly.
Pick it up in Mars. Yeah.
Now, 1,500 watts near a pyrotechnic charge?
Yeah.
Maybe not.
Yeah.
But in theory, you could easily use like a small amplifier and run several watts. And as a radio guy, that's part of the fun for me, is as I launch these, I'm starting to have them just beacon out generic messages. And I'm telling all my radio buddies, hey, I'm doing a launch on Saturday. Watch on Mastodon, because I have my dashboard set up that it sends messages out to social media during my countdown and during the launch. Cool. So it's actually sending my telemetry data as Mastodon posts. So I tell them, hey, watch for the launch and see if you can hear me. So I get all my buddies to turn on their radios and see if they can pick up my signal from, wherever they are. So
any luck on that, or what's the furthest you've gotten a bite on?
The LoRa doesn't have a real long range. So far I've only heard my own signal. The APRS piece of it is what's kind of fun, because the ham radio community has like a whole infrastructure for this APRS messaging already in place.
Right.
So there's ham radio people all over the country that operate what are called iGates. So it's basically people who have receivers running all the time and just receive and collect data that anybody transmits, and then they all feed it into an online database. So with the APRS, if you have one of those trackers in, you can literally log into a website afterwards and see what all stations received your signal.
Oh, nice.
So for that, the most I've gotten is, line of sight, it's probably 5 or 6 miles to the one iGate in town near me that picked up our APRS packets.
That's pretty damn good, actually.
Yeah.
Yeah.
Wow.
So that's kind of for me, the fun of it is the radio stuff is, launch it up there and see how far my signal goes.
Oh, sure. And like right now, when you first started out, you were just seeing if you could get signal and get something back, right? Now, like as you're going forward, what are you thinking of what you'd like to see, besides all the X, Y, and Z axis stuff?
Yeah. So, well, the pieces that I'm playing with now, there's a combination of stuff. So in version 3 that I'm building right now, which I've taken a step that's even new for me. One of my good ham radio buddies is a guy named Mark, and he convinced me to design some of my own circuit boards. So for version 3, I'm actually designing, and some of them I actually have already. So version 3, the sled is actually the circuit board. So I'm basically designing little discs that carry all of the parts that I can like stack together.
Look at
modularly.
that stack. I was just about to say, I see that stack right there.
Yeah. So basically they all kind of like stack up and then use these discs. And I've made the discs, I have several different diameters so I can use as spacers. So I have 38 millimeter ones. I have ones that'll go up to like the 41 and a half. But basically I have like the mounting points in the middle so that I can just make wider and wider discs for bigger and bigger airframes to kind of carry this stack of stuff. Yeah. And but so that's one of the pieces is just the circuit board design. So basically, rather than a whole bunch of wires running all over the place in the rocket, the circuit boards that stack actually contain all of the signaling wires between the different modules. So instead of a bunch of wires, it's just plug one on, plug one on, plug one on, and there's no loose wires.
And you just use like any like PCB way or some other circuit board printer for that stuff?
So I used KiCad, the software to design them, and I used JLPCB to get them made, which is, they come from China, and it takes 4 weeks for them to get here. But it's like $5 for 5 boards.
Right.
So every time I do an iteration of design, like I need 1, but I get 5. So at some point I'm going to have a bunch of extra, and I'm going to be like pinging out on social media, like, hey, anybody want some of these to play with? Because I'm ending up with a box full of them. But yeah, it's real inexpensive. So the learning how to use KiCad and do the circuit layout design stuff was way more challenging than getting them manufactured and
I
shipped.
believe that.
So
sure.
So that's the one piece.
What we're going to do is I'm going to put a hold on right there because it's a convenient point to keep people hanging for a break here. And we'll be right back. We're talking to Vance Martin, a Rocketeer and ham radio operator. He's got a very interesting electronic project going on, telemetry and all that from his rockets, just like I do. And we'll be back with more right after this. And it's time for eRockets.biz. eRockets.biz is your home for unique model rocket kits as well as the world's largest selection of rocket parts from Semrock. They've been in business since 2009. eRockets.biz has a wide selection of your favorite kits as well as their own versions of popular out-of-production models many of you have come to enjoy over the years. And, Jim, you've been checking out the websites. What did you find?
I'm always checking out those websites. Absolutely. Well, there's a buzz going around the community that I have been taking a look at and seeing on all the social sites and everything. And it is a great rocket that has come up. It is the Estes Pro Series Great Goblin. Now, get this. It is a 3-inch diameter Estes Goblin, right? It's 33 and a half inches long.
Okay.
It weighs about 16 ounces. And, of course, it has the 29 millimeter motor mount. So there it is, guys. Estes has come out with a Pro Series Goblin for all you Goblin heads out there because they did the Red Max. Now they did the Goblin. So it is a really cool rocket. Now, there are also some modification kits because it does come with balsa wood for your fins. If you want to go a little beefier, there are mod kits out there from a couple of vendors that you could do plywood if you wanted to. Or you could just, stiffen up the balsa wood. So there's many things you get. It comes with everything you need as always. You've got... let's see, their cover system is a 24-inch parachute. It's the red Estes one. Fin materials, laser cut balsa, 29 millimeter motor mount, and of course you get the motor retainer with that. Those famous Estes motor retainers that seem to always last for how many flights? 15, 20 maybe, or more that I know of. So this is the kit to get if you guys want to go back to the old days and beef it up a little bit with your Goblin. I don't think anybody who is a Rocketeer has not built a Goblin. It's always the Goblin and the Red Max. I mean, I had both. I'm a Red Max team, but I'm definitely going to go Team Goblin on this one. So, and it is available at eRocket, so you guys better get it. There's all sorts of talk and buzz going on about the Great Goblin. It's at eRockets, and you can get it right now for $64.99. So go for it, guys. You get them before they get sold out, because this one is going fast.
Nice. And there are also plenty of other rocketry items you can choose from, such as educational rocket kits and supplies, air rockets, water rockets, and so much more. eRockets.biz certainly has enough kits and supplies to keep you busy in your workshop for a long time to come. If you need parts for your own custom builds, that's not a problem. eRockets.biz also supplies the Semrock line of airframes, nose cones, centering rings, motor mounts, and so much more. eRockets has more rocket parts available than anyone else on Earth. So check out eRockets.biz today to learn more. eRockets.biz. If rocketry scares you, buy a train set. North Coast Rocketry, established in 1984, is the company that practically invented the class of rockets known today as mid-power. North Coast Rocketry takes advantage of over 30 years of high-power experience by a world-class rocketeer. North Coast Rocketry features a wide range of unique kits to expand your personal high-power rocket fleet. When you see an NCR rocket fly, you will encounter an absolute treat of sight, sound, and performance. Once you own and fly a North Coast Rocketry kit, your rocketry hobby will never be the same, and neither will your rocket fleet. In addition to great kits, North Coast Rocketry also stocks lots of must-have items and accessories for every Rocketeer's workshop. Go to NorthCoastRocketry.com today to find out more about these kits and other great products. NorthCoastRocketry.com. Advanced rockets that are easy to build, fun to fly, and look great on display.
Hey, all you rocket geeks out there. Do you like doing in-flight videos of your flights? And do you ever use those keychain cams and unfortunately sometimes only get videos of your thumb? Hey, this is Gene from The Rocketry Show, and that used to happen to me. I used to use those old keychain cams only to get nothing very good quality. But I found a solution to that, and it's Insane Rockets. It's an app that's available on the Google Play Store for Nexus 5X and higher. Now get this, it does 4K video. But not only that, it'll upload it automatically to the cloud and provide you real-time telemetry while tracking your rocket through Google Earth. It is amazing. Available on the Google Play Store, Insane Rockets app. It's crazy. No, wait. It's insane.
All right, let's take a moment right now to thank some of our patrons of the Rocketry Show here. I'll start with thanking Todd West and Jonah Cheney, also Matt Tudor, Joseph Petro, Les Rayburn, Steven Spencer, Bill Cook, Jason Cook, Gary Rosenfield, and Ken Blade, Eric Hamilton, John Beans, Scott Holla, Guy Wadsworth, and also Phil P. and Tom Rum and Stephen Ray. We've got a few more. Gene, want to take some from there?
Sure. We go with Amanda Ho, Steve Sainer, Mark, railbuttons.com, Randy M., Philip Kelly, everdonrocketry.com, the High-Tech Redneck Rocketry. Thank you very much. That's Stacy Worley. Jim Fields of Michiana Rocketry. Thank you again. Brent Nowaki is awesome. Thank you. Alan Wellington. Alan, we have missed you a couple of times on that, and we do apologize. So I'm giving you an extra double whammy shout out for Alan Wellington. Thank you so much. Timothy Mock, Team Semrock, and Trucker Jim. That's Jim Wilson. Phil Bridges, Roy Tyson, Gary Dow, Alan Wellington, Don Johnson, and Pierre Marlowe.
All righty. And we'll thank our patrons there. Thank you so much for your support of The Rocketry Show. We'll have more in the next break. Welcome back to The Rocketry Show at TheRocketryShow.com. We're talking to Vance Martin, who is an amateur radio operator and licensee. Call sign N as in Nancy, 3 V as in Victor, E as in Echo, M as in Mary, and 3 VEM as his call sign. And he's got the Radio Rocket Project that he's been working on for like a little over a year now. And he's got a whole website for it and all that stuff. We'll link to that in our notes if you want to check out what he's doing. He's got a lot of cool pictures to go along with what he's describing to us during the show. And so you're about to jump into your software stuff and what you're using that way. So I stopped you right there for the break, and so I'll let you pick up from there.
Cool. Yeah. Yeah. So the software side of things, the piece that's new that I started playing with. So I'm using, this teensy microcontroller, which is standard Arduino programming. And the first two versions of the Rocket, I was basically just reporting raw telemetry data from the sensors. I wasn't trying to do anything with it. I was just spit the data out, receive the data, and view it. So for version 3, what I've been working on now is starting to like do stuff with the data. So the piece that the hurdle that I just got over actually this week was taking the raw gyro, accelerometer, and magnetometer data and feeding that into some libraries and algorithms that will convert that data into like your yaw, pitch, and roll information, which is really cool because now on my dashboard, I can stick a little icon or something and say, okay, the rocket's nose is pointed up. Whoop, now the nose is sideways and now it's pointed down. So I really hope the parachute comes out soon. So some of that basically starting to make that raw data meaningful is what I'm dabbling in now, which has been a lot of fun. And I have like certain things. Basically, I have radio messages sending when telemetry events like, apogee and deployment and things like that happen. Right now, I'm not doing anything with those because I'm just relying on motor ejection. But kind of the next phase will, after I get a few more launches in, will be to basically get up the courage to actually let my electronics fire the deployment charges and things like that.
What I did leading up to that on the rockets was I did a series of flights where the flight computer was there and thinking it was controlling events, but since I had a telemetry link, it was radioing back what it was thinking it was going to do, what it thinks it was doing, and just to see if it would really work. And after a couple of flights, looking, oh, look at that, it seems to be detecting apogee just fine. Oh, you put a chart, fired a third. Then I went ahead and went with an apogee ejection and did the standard. But no, what I had in there was the chute release, just for parachute, opening, But I just started with apogee only, and then there was a motor backup in there anyway. So I set my motor charge longer than electronic. So if it didn't work for some reason, at least
still had the motor.
Open the rocket up.
Which is probably a good tip that I should probably follow in that path when I'm ready to make that step.
Here's the one thing that like when I do a flight, I love to watch the rocket while it's doing something. And I've been on CG's flight crew where I was watching the base station and I wasn't watching the rocket flight. If you're doing this on your own, are you watching the data or are you watching the flight? Are you trying to get both? I mean, it's kind of one of those, well, what do I watch? What do I see? What do I,
It's funny, even though the electronics is the part that really fascinates me from building it, it's hard to not watch a rocket that's launching. I mean, I don't know what it is, but it's so I tend to watch the rocket, but what I've been doing is doing just a screen recording of the dashboard so that I can go back and kind of watch it after the fact. And I capture all the data so I can actually replay the data log through my dashboard. So after the fact, I can actually rerun the data through the dashboard to, test stuff and poke at stuff. And then the other thing I did with Node-RED, you can add voice modules so you can get the nice voice announcements. So I have a little speaker sitting there beside the computer. So it just shouts out, apogee detected. And look at that. So the voice, I tend to listen to the voice announcements and watch the rocket, and then look closer at the dashboard stuff after the fact.
I'm thinking VR headset right now.
The augmented reality stuff. Like that's the next project, right?
See, what I was doing is I'll watch the rocket because I'll probably have a heart attack if I wasn't. But that's when I get my friends like Jim or Andrew or whatever. They sit at the mission control, as I call it, looking at all the data on the screen with the radio, two-way radio, and radioing back what's going on. So that's my computer voice or humans. Yeah.
Nice. But so that's a lot of the stuff that I'm working on right now. And then the next step that I want to do, again, being the radio kind of nerd that I am, is there's two pieces. I would like to build a small amplifier in there for the LoRa radio just because I can, just to see,
how far can you push it?
How far can I get a signal and get some of my buddies to receive it? And then The other piece that I want to do with the radio stuff is part of, something that's real popular in ham radio right now on the high frequency bands, which are generally not used for this type of telemetry stuff. But there are data modes on HF where hams will talk. It's basically keyboard to keyboard. You hook your radio to your computer, you type messages into the computer, you do stuff in the computer translates it, sends like terrible noises like your modem used to back in the day.
Yeah.
And then your buddy's computer on the other end picks it up. So the little light APRS board that I use, there's a light APRS W2 version of that can actually do some low power HF stuff. So the next thing that I want to try once I get some of this basic stuff working is actually at Apogee sending a couple of these data beacons on HF, because those data beacons, even at low power, like a couple watts, people will get signals into Europe and Africa.
Jeez.
From the US. So
Nice.
That's really the next thing I want to do is at Apogee send a beacon and then see what HF signals I can get received from this rocket.
Oh, sure.
Literally around the world, because these modes, FT8, for anybody who happens to be a ham listening, FT8 is the mode that I plan on doing that with. The trick, ham radio HF frequencies are super low frequencies,
Right.
which means they need really big antennas.
Yeah.
Right.
So getting a really big antenna in a really small rocket is kind of a trick. So I've actually already built the antenna. So it's what's called an end-fed antenna. So it's basically just a long piece of wire with kind of a loading coil at the bottom that would attach to the board. And my plan is basically to have like a 40-foot long shock cord.
Yep.
So that this antenna wire can kind of be fed up through the tubular, Kevlar or nylon or whatever, so that when it deploys, basically when it's hanging under its parachute, that super extra long shock cord would essentially have the antenna running up through it. So that's the next thing that I want to try, is to get some
very cool.
HF beacons out. So
I mean, my shot cords routinely are 50 feet, for my big stuff. So it's not a big deal to do that. So, and it's cool.
Well, I guess at mid power, it might look a little strange, but I guess you're right. Yeah. The high power rockets pretty often have their shot cords that long anyway.
I was dual deploying on G motors. Come on, on a low power fields, because I could.
Yeah.
Me on
Very
F,
cool.
F and G motors. No, E, I think as well. Yeah, E, F, and G.
I saw you fly. I saw you fly an E dual deploy over at the low power field one day. I was early when I was just starting to get back into it.
Okay.
So I thought, wow, this guy's cool. I got to know what he's doing.
Yeah, that was in the that was before the electronics got quite small enough to fit inside of 38 millimeter airframes, which is kind of funny that you're on 38. 38's kind of where I test everything first before I go into the larger sizes of high power. Yeah. So,
Vance, are you doing any kind of little hatches with little screws? Because CG does that all the time. He's got these little hatches with these screws that he does stuff with.
So, it's funny. After CG pinged me, I actually went back through and looked at some of projects in the past. So I saw his radio stuff that he was doing. I was like, oh, this is like kindred spirits here, doing all this telemetry radio stuff. But I did see your rocket that starts with the N name that you have kind of all modular. Yes. Yeah, I did see that. I was like, oh, that is really cool. All the modular stuff. So the electronics that I've been doing, I've been building the electronics modular so that I can plug pieces on and off. But so far I'm doing them so that basically I can just slide the whole thing down in the payload bay and slide the whole thing out. I haven't gotten brave enough to start trying to put little hatches and stuff in the rocket yet.
little wire raceways on the on like I do.
Yeah, he's running conduit up the back, with JST connectors or whatever it was.
The conduits on there.
Very cool. So JST connectors. Ooh, don't get me started. I think I might hate JST connectors. I'm not sure if it's founded or fair, but
I'm not going to disagree or agree with you. I mean, there's there's the RC radio guys love them. The car guys.
I have the JRC ones inside, but for disconnecting, I just use those little 2-pin headers that just slide into the and mating male and female connector, like what's in your PCs on the motherboard.
Yep.
And
and that's what I'm using on. So my little stack thing that I started building, that's essentially the physical connecting mechanism. It's that same type of connection, but it's the one that's 2x10. So it's 2 rows of 10 pins that plug together. So one, it gives me like 20 different signal lines to send between all the different modules. But two, it's a decent size that it creates a strong enough physical connection that essentially as I plug those and stack them together, they make a real nice little nested assembly that slides down in.
When you're doing the design of some of these boards for different capabilities, do you keep in mind, well, I may want to put something else on that, in the future and, just to keep it going?
Yeah, there's some of it is stuff that I've probably over-designed because I didn't know exactly what I was going to do. So like the 2x10, basically leaving 20 signaling lines, I think I'm only using 4 of them.
Right.
Because the other ones I figured, well, at some point, if I want a module to do something else, I'm going to want to access one of the other pins on the microcontroller. So basically, right now, I have 16 extra pins. The 2 of the modules that I have the parts ordered for that, the little discs are actually on their way across the Pacific right now. And my Mauser order of all the little parts and bits and bobs are on for the new boards that will be the deployment boards, basically the ones that will fire the charges. Those I'll use a couple extra pins because I'll need, basically a pin per board to kind of like be the signaling to fire the charge. So right now I gave myself what I think is plenty of extra.
It's more than enough, until you run out.
Yeah, until I run out. And I'm sure at some point I will probably say, I just need to go bigger and, give up on keeping it at 38 millimeter and start building it into bigger ones so that I can get more lines.
And you're not a level 1 yet, or you are?
No, I'm not level 1. I built the rocket and never launched it. It's actually hanging from my ceiling behind me as kind of like my reminder that I have never done my level 1.
Your motivation.
Yeah, well, and it's one of those where like, in theory, I could take that and use it for my level 1, but I built it when I was 20. I'm in my 40s now. Like, it's a rocket that literally sat around for 20 years. Do I really want to launch that one, or do I want to like
old epoxy, man?
New?
It's funny with Nezru. I was building that to be my level 1 rocket. It turned out to be that, but a lot of the things that it was just built to be a motor deployed level 1. And that was kind of like boring because I was already doing dual deploy at mid power.
Right.
So I was like, well, I guess I'm going to go dual deploy on this. So I had to kind of redesign it again. So that modular stuff came in handy. So there are sections of the rocket that were designed for the first flight that never flew because I went and converted it into a dual deploy and flew that on there.
See, and people said I was nuts to dual deploy my level 1, and I did it.
Yeah. The people basically, there were people telling me the same thing. It's like, oh no, I would just do it fast, do it simple, and just get the certification.
Bring it up, bring it down. Yeah.
Oh, what fun is that?
Right?
So it took 2 failures to get it. On the 3rd time, I got the level 1 with that one, but
1 failure for me, but same day. So.
See, what was it? The first one was launching on a cold day, so I was using alkaline batteries for all that stuff.
Womp womp.
Okay.
So I was testing out all that stuff all summer long in rockets, but on that day it was a cold day, and I was using the little A23 batteries, and they were working great all summer long. But when I was using them in the winter, they just didn't have the oomph to set those igniters off. So that was the first failure. So I went back and the RC folks told me, well, LiPo batteries, they like the cold. And so I was like, okay, great. So I tested out and figured out how to use those safely, and then turned around and did another launch a few months later. It was still in the wintertime. Everything worked great except for there's a hole that I filled with aluminum tape with the idea I was going to fill it with epoxy. So the aluminum tape was just going to hold the epoxy in just to cover up the hole. But I guess in all the other work, I thought I covered that up with epoxy, and I didn't. So when the charge went off, it just kind of blew a hole in the aluminum tape and just vented all the pressure out through that. So, found that one, was like, okay, the 3rd time, finally.
Nice. Yeah, and for me, the trick with the reason I never did the level 1 when I built the rocket, I was in college when I finished building it, and I didn't really have easy access to a club that had
Gotcha.
a high power
Mhm.
field, and I still don't have easy access. I'm technically within driving distance of the club down on the eastern shore of Maryland, where
Murder or whatever.
Steve
it is.
Eves
Yep.
did his big giant like Mercury launches and stuff.
MDRA.
Yes, MDRA.
Yes,
Thank you. So that's like a 3-hour drive for me. So that would be doable. But we've got 4 kids, so to drive 3 hours away
Yeah,
on a
gotcha.
Saturday. So basically, when I started getting back into this, I kind of said, well, for now, I'm going to try to design everything at mid power because I live in Amish country. Like I
Yes.
walk out my backyard and it's 100 acres of
Field.
Yeah.
field. So in the summertime, I can't launch as much. I have to go over to the local high school and we have to keep it lower. But in the wintertime, I can go back there and,
Let her rip.
stick, the biggest G in that I can and,
Yep.
and let it rip.
How many times were we in the cold, CG? Like,
Yes.
like in the middle of an old cornfield out in
Yes.
Amish country.
Yep.
Sitting in the car, keeping
So-
your hands warm because there's nowhere else to go. Yeah.
Yep. So now luckily, because the development I live in, we're literally against the field. Like I literally just walk out of my backyard into the field. So if we
Nice.
get cold, we can just run back into the house for a little bit. So
Great. We're going to take another break here, our final one for the show here, and we'll be right back with Vance Martin on The Rocketry Show at TheRocketryShow.com. Stick around. We'll be right back. It's time for Serious Rocketry. Serious Rocketry since 1998, providing the Rocketeer with great kits, motors, supplies, and more. They have lots of products in their ever-growing web store with fast shipping, wide selection, and courteous service. You can also check out the amazing and popular Serious Rocketry kits that harken back to the days of fun-to-build detailed kits that are more than just 3 fins and a nose cone. And, Gene, what did you find on the Serious site?
Oh, there's always so much to find and always so much to poke around in. But, there's one thing that I don't believe we've actually touched upon, which is actually kind of funny. As you're going through your rockets and, sometimes you have a park flyer that you want to put a bigger motor in, or sometimes you have a bigger rocket and something's going on the range and your electronics aren't doing very well. Well, how about a Jolly Logic shoot release? I mean, it is a wonderful little device. I mean, I had a chance to meet John Beans and talk about his product a few years back. And it is an amazing little device. It's basically a rubber band that wraps around your parachute and you set the altitude that you want it to spring and open up your parachute. So it's like it's like a dual deploy system because the ejection charge from your motor will eject the nose cone and the bundle of the parachute with the chute release. And at whatever altitude you have chosen for that chute release, usually I'll do about 300 feet for a chute release, it springs open and fluffs out your parachute. It is an amazing little device. I have about 5 of them that I've used over the course of the years, and I absolutely love them. And I know a lot of flyers out there have them, but if you don't have one yet,
Yes.
you need to get one. That's just it, flat out. You need to get one. Serious Rocketry has them. They are going for $139.95, and it is a great way to add dual deploy to a pre-built rocket. You could put that around your Great Goblin, I would think. That would also be a nice little touch. So the chute release is an amazing device. You get extra bands and some other accessories with it, including a charging cable, which I thought was very nice. And it's really well done, well built, and they go through a lot and they keep on coming back. They're just amazing little gizmos. I absolutely love them. Get yourself a Jolly Logic chute release if you don't have one. If you do have one, get another one from Serious Rocketry. They're going for $139.95 from Serious.
All righty. And Serious Rocketry's website features real-time stock tracking, which lets you order with confidence from their online store. No having to call or write to see if something is really in stock. And when you're ready to fly, Serious Rocketry has motors and hardware in stock from Estes through Aerotech High Power, as well as popular electronics from Jolly Logic and more. Be sure to ask them about their club specials while you're at it. So check them out today. Visit Serious Rocketry today at SIRIUSrocketry.biz and .com. Serious Rocketry for the serious Rocketeer. Lock Precision Rocketry manufactures a full line of high-quality precision-fit electronic bays, motor mount adapters, recovery hardware, and harnesses, all designed to meet your building, repairing, and customizing needs. Lock Precision believes in making rocket kits as light as possible while maintaining the strength required to fly with commercially available motors. When you visit lockprecision.com, be sure to also check out their wide range of rockets, such as the 4-inch Mystic Buzz, the 4-inch Lock Goblin, featuring multiple motor mount adapters for 29 and 38 millimeter motor mounts. If you're looking to gain entry to high-power rocketry, then you can certify for your level 1 in style using the Lock 4 rocket kit. Lock features rocket kits for all flyers, ranging from entry-level builders to experts. The name Lock Precision has been synonymous with mid and high-power rocketry for over 30 years. Check out lockprecision.com today to find out why. Find your airspace with lockprecision.com. All right, before we get back to the show, let's thank some of our patrons of The Rocketry Show. Gene, you want to start?
Sure. Thank you, Jeff Curtis, John Bryan, Casey Anderson, my buddy. Thank you. Mark Essenwine, Norman Perkel, Jimmy Burgess, Paradise Rocketry, Jason O'Shelley, George Raker, JohnRocket.com, Jason Rodney, Conway Stevens, Paul Oliveri, Sam Feinberg, John Sicker, Sean Falkingham, Brian Scheckenberger. And then we're off to John Thompson, Mark McBride, C. McCauley, Rocket Lab Delta, Carl Hunting, Bryce and Nicole. Thank you. That's a new one. And the last one that I'll do before I pass it back to you, CG, is the Piedmont Student Launch Team. Thanks, guys.
All righty. I also want to thank Chris Irving and David Simmons. And SBR Rocketry, FusionRocket.biz, John Kusher and Kelsey Black, Brian Renneker and Jerry Krause, also Justin O'Neill, Terry Dancer, Mike Krupe from Mock Performance, and Brett Grasmick. And thank you all. And if you want to show your support for The Rocketry Show, just visit us at support.TheRocketryShow.com. Thank you so much for your support, patrons of the show. And now, back to the program. Welcome back to The Rocketry Show at TheRocketryShow.com. I'm CG, and Jeem is with me, and we have Vance Martin, a ham radio operator who is into rocketry and his Radio Rocket project, which is a big telemetry thing. So we've been having fun geeking out about tech and rockets on this episode here. So we were just kind of talking about the flying out in Amish country and how much fun that is. And how convenient it is.
How convenient it's outside. So Vance, moving forward, what would is there like a holy grail project that you have in the back of your mind that you want to achieve, but it's so out there that it may not ever happen, but you still want to try?
Well, the most obvious thing is I got the high power bug when I was in my 20s and built the rocket for it. So ultimately, like I still want to do that, as my kids get older and can make the trip with me down to, 3 hours in the car down to Maryland. Like I would really like to get into the high power stuff. Just because I'd like to kind of do essentially the same projects, but just getting them much higher in the air.
And a bigger payload bay too.
Yeah, bigger payload. And, because there's all kinds of stuff I've schemed with, this little system that I'm designing. In theory, I could keep this kind of the same modules, but just like you can stack, just like you can cluster engines, you get a big body tube and you can fit the equivalent of like 4 BT60 diameter things inside of a bigger tube. With this modular system I've been doing, it had dawned on me that I could do like 4 or 6 inch end caps that have multiple like sockets. So I could basically plug multiple stacks. So I could take this whole thing and instead of being one long stack, I could have like 4 short little stacks and I could sandwich the whole assembly into like probably just, 3 or 4 inches tall. So I'd like to do some of that stuff, if I ever get around to the high power pieces. But yeah, right now it's just, I've been having a lot of fun with this.
Oh, absolutely.
The
Yes.
cost wise, I'm not, because I'm still very much a rocket noob. I know there's some commercial stuff out there.
Mhm.
I know some of it's very affordable, and I know some of it is wildly expensive.
Yeah. Kate's.
So,
Kate.
yeah. So ultimately, I'd like to, like, these designs and stuff. Like, I have no interest in like trying to make money off of any of my hobbies ever.
Right.
But I would, if this stuff works out, I would like to make sure that I publish and get the designs out there, so that if somebody wants to do something similar, they could basically download the files, order their own boards from JLPCB, and kind of mimic what I did to play around with it. So I would really like to do that as I continue on this path. Just kind of make it available as a
good project.
I haven't added up the dollars to see if it's any cheaper. Like it feels like maybe it might be, but then I sit down and I go, I don't know. I think I might have racked up a couple $100 in this already. So
Sounds familiar.
Well, it's easy to do while you're developing things, but once it's all said and done, and ultimately, a lot of the expense is going to be your time. So, but it's a hobby, so that doesn't really matter. But ultimately, when you go to duplicate that for future, like with my rockets, I want to have all of them have their own electronics package in there, and when you get to that point when you're doing it, then it's a lot cheaper.
Right.
But in the beginning, it's all the trial and error does add up.
Yeah.
So.
Yep. So yeah, that's kind of the piece that, from the rocketry standpoint, and then from the ham radio standpoint, because that's kind of where I actually got into all of this.
Sure.
And ham radio is traditionally thought of as like, oh, that's like an old guy's hobby. And they're always talking about like, well, how do you get young people interested in ham radio? So in the ham radio community, a lot of the conversations I've been having around this project are like, hey, this is cool. Like, kids like rockets. Like, this is a radio thing you can do that gets like younger generations interested in the hobby as well. So there's some really neat crossover in ham radio and rocketry.
Yes.
That I think both hobbies can really kind of benefit from each other. So that's just in growing what are otherwise niche little hobbies. It's kind of a neat crossover space to sort of,
there's a lot,
bring the two communities together.
There's a lot of like ham. I know a lot of ham people do rockets, which is kind of, you're right. It is a nice crossover.
There's two ham radio people and model train people.
Interesting.
Yeah. Yeah, and I never quite figured that out. I mean, I can understand the ham radio because like what you're doing, or I can appreciate all the stuff that goes into that, and especially if you're a radio enthusiast, you want to build your own stuff. I get it. So the train thing haven't quite worked out yet, but
yep.
So. Yeah, I have a train set, but between the studio and my workshop for the rockets, it's taken up all the space in the basement that the train set used to occupy.
Yep. Yeah. All my hobby stuff has to fit into the room that I'm in. So,
there you go.
This is like my one space. So.
I'm gonna like duck out of the picture here real quick. See that room? That's my room.
Yep, there you go.
Looking at lots of rockets, actually, for the radio guys out there. So
rockets, and more rockets. So when you're with your modular design thing with your electronics, it's kind of reminding me of where I'm kind of headed with my stuff, because in the rockets right now, everything has been on a single board, sensors and all. And if I want to change one little thing, the annoying part is that I'm surface mounting a whole bunch of the same parts on different boards over and over again. So I was thinking, well, I think I'm going to have something that's like a sensor package, and if I'm changing out the brain of the thing or some other stuff, it just kind of ties in and connects to the other parts, as I'm changing just that one little thing, rather than building an entire flight computer every time I want to make a change. So that's so your disk ideas are kind of like, that's a way to do it.
Yep. Yeah. And that's really exactly why I did it, because I didn't know exactly what I was going to do when I started putting the pieces together. And so as I got started on version 3, I said, well, how can I make this modular? So, basically each disk, if I want to try something new, I can design a new disk with just like whatever needed sensors are on it and plug it onto the stack. So the things that I have, basically the parts that I currently have stuff, coming across the Pacific to me, is I basically have like what I call like the brain module. So it's basically the carrier for the microcontroller.
Okay.
And it's actually a little horizontal board, but then I plug 2 discs onto the end of it to kind of activate spacers. And then I have the like the power, what I'm calling the power board coming. So that's the one that basically carries the battery and then also has the switching circuitry to basically power the whole thing on and off. So I have like the little power board. And then I have the radio module. So the little carrier for the LoRa and the APRS.
Yep.
And then I basically made a bunch of like essentially blank, what I almost like breakout boards. So basically blank discs that just have a whole bunch of little holes in them so that in theory, if I want to experiment with something but don't want to have it actually fabbed up, I could just go to like Radio Shack and grab some transistors and stuff and almost breadboard style put them onto one of those like experimenting perf board discs and play with it that way before actually fabbing up an actual disc.
Cool.
So those are the pieces that I have right now that I'm working with.
Very cool. Excellent stuff.
Yeah, indeed. So yeah, the one thing that I noticed, like when you were talking about just doing the hobby and not really looking to make a business out of it or anything, as people were watching what I was doing, a lot of them were like, you should sell those. And, and for a while I was kind of thinking about it, but all it did was jam up my brain to the point where I didn't want to do it all because it was like, well, another job, I already have a bunch of other jobs right now. And it's like, this is my hobby.
You're not doing it to make money. You're doing it because you want to.
Yeah. As soon as I took that off the table, like, I'm not going to, this is just for me. And then I was inspired again. So, so I know exactly what you're talking about there.
Very cool.
Well, cool. I'm looking forward to seeing what happens in the future and watching your Radio Rocket project. And yeah, we'll have to kind of check in with you and see how things are going in the future here.
Good deal. Yeah, well, I'd say, follow along on Mastodon. Anybody who, I know a lot of people are trying out new social media stuff. So Mastodon is the place to probably keep up the best with the Rocket project. And I have the ground station unit actually sending live launch update stuff. So in theory, if you are on Mastodon on launch day, you can actually watch the rocket send its toots, as people do on Mastodon. So the rocket sends out its messages, launch detected. And
so for those that are on Mastodon, what's your tag that they should search for?
So it's the rocket itself. I have an account just for the rocket. So that's Radio Rocket at mastodon.hams.social. So it's a ham radio specific channel. And then me personally, I'm N3VEN at mastodon.radio.
Okay.
So.
Very cool.
Cool.
Yep.
All right.
I just followed you on Mastodon, so.
Awesome.
Cool. All righty. So enjoy it and keep us posted. I guess you will if you look at you on Mastodon there. And we'll look forward to seeing what's next for Radio Rocket on this project here.
Sounds good. Thanks a lot, guys.
Thank you.
Cool.
Have a comment? We'd love to hear it. Send them to mailbag@TheRocketryShow.com. If you enjoyed what you heard, don't forget to check out our sister show, TheModelRocketShow.com. The Model Rocket Show is hosted by the Rocket Noob and is all about low to mid-power rocketry. TheModelRocketShow.com with Daniel, the Rocket Noob. Check it out today. The views and opinions expressed on these programs are those of the participants and do not necessarily reflect those of Little Beth Entertainment or its sponsors.